A student stands to perform an experiment to determine the electromotive force EMF E and the internal resistance R of a given cell using a graphical method. An incomplete circuit diagram that can be used for the experiment is given below. The student is provided with the following items: milliammeter, digital voltmeter, standard resistor, keys. There are two keys. First one is a tap key and second one is a plug key. There are two types of keys. Part A. Complete the circuit diagram correctly by drawing the appropriate symbols of the items given above. We have to remember when finding internal resistance of the battery, we have to find the voltage, terminal voltage of battery. It means voltage drop between two terminals of battery, and current through the battery or current through the circuit. Then I will draw the diagram. This is a battery. In a battery there is a internal resistance. It is marked as a series resistor, simple R. EMF, electromotive force, means voltage of the battery, terminal voltage of battery when if there is no current flow through the battery. And we have to connect a key to this place. Normally we are using a tap key to the primary circuit because of we have to on this key only when using the circuit. If it is continuous, if we are getting switch on condition continuously, the battery will discharge. Therefore, we have to use the tap key. And to measure the voltage across the battery, we have to use a voltmeter. Then we have to connect voltmeter to this place. And there is a rheostat in the circuit. Rheostat means we can change resistance of this resistor. Variable resistor. It is a type of variable resistor, rheostat. Then there are two blank spaces and there are two instruments, a 10 ohm resistor and milliammeter. We can connect 10 ohm resistor and milliammeter to these two places. If you are marking milliammeter at this place and 10 ohms in this place, it also correct, but other elements should be placed correctly. It is answer for part A, completed diagram. Then part B, 1. Name the type of key that the student must use. Tap key. Then part 2, give the reason for the selecting the key to avoid discharge the cell, to avoid discharge in the cell. Or we can write to avoid increase the temperature of the circuit. We know that if there is a continuous current flow, the circuit is heating. Then part C, Write down an expression for the voltmeter reading V using the milliammeter reading I, EMF E and internal resistance R. Milliammeter reading I, it is current through this line. And they have given a digital voltmeter. And they have not specially given the resistance of the voltmeter. Therefore, we have to remember internal resistance of the voltmeter is infinity. We know that for an ideal voltmeter, internal resistance is infinity. If the internal resistance is infinity, it means there is no current flow through this line. There is no current flow through the voltmeter. Then we can get this current is equal to the current through the cell, and it is a discharging cell. For a discharging cell, terminal voltage should be equal to EMF minus IR. EMF minus IR. It is the answer for part C. We have to write only the answer. Part D. To plot the straight line graph, the student must select appropriate 6 values for the independent variable. How does the student identify the approximate range for the independent variable in order to select its suitable value? He has to change the resistance of this rheostat. But we have to write the method. First, close the tab key. Close the tab key. And in rheostat, there is a sliding key. Slide the key in rheostat to control the milliammeter reading. We can control the milliammeter reading by using rheostat. When sliding rheostat such that sliding the key in the rheostat such that its resistance is increasing, we can see the milliammeter reading decreases. Then part E, write down the procedure that the student must follow to take reading. Part E, we have to measure. Method is given in part A, part B. Therefore, we have to write the method. We have to reading. Measure voltmeter reading with the considered milliammeter reading. We have to control milliammeter reading by using rheostat, and we have to get voltmeter reading for corresponding milliammeter reading. We have to decide milliammeter reading first, and then we have to measure the voltmeter reading corresponding to milliammeter reading. Then part F. In this experiment, the graph plotted by a student is given below. Calculate the gradient of the graph using the suitable points. Again, we have to consider suitable points. When getting suitable points, show the graph in the marking scheme. We have marked 3 points. We can consider 2 corresponding points. I will consider this point and this point to calculate gradient. You can mark corresponding points. We have to consider when getting gradient. Now I will calculate the gradient. Then we can write gradient equals difference of y divided by difference of x. F part 1. Gradient. When getting gradient, the y value for the difference of y value for the corresponding readings 1.2, 1.3, 1.32, 1.32 minus 0.86. This is the difference of y value. Divide by corresponding difference of corresponding x values. 30 minus 110. But you can see the graph. X-axis in milliampere. We have to use SI unit 10 to the power minus 3 ampere. Then you can simplify it. 12 minus 6, 6. 2 minus 12 minus 8, 4, 0.46 divided by minus 80 into 10 to the power 3. Then answer is minus 5.75 ohm. It is in ohm because of y-axis divided by x-axis means V divided by I. We know that according to V equals IR, V divided by I is R. Then it is a resistor reading. We can get unit of gradient is ohm. Then part 2, determine the internal resistance R of the cell. When getting R, we have to consider the equation. V equals E minus IR. V equals E minus IR. And we know that gradient, we are changing current. Then I will rearrange the equation. V equals minus Ri plus C. Y equals minus Mx plus C. Now we can get gradient equals internal resistance. Gradient of graph equals R, and then we can get R value is 5.75 ohms. We have to consider only magnitude because of there is a minus mark for both values. Then part 3, determine the EMF, E of the cell. When finding EMF, we know that EMF is the intercept of the graph. We can produce the given graph to get the intercept like this. There is a graph like this. We have to produce this graph up to y-axis, and this value is the EMF. When producing, we can see that the graph is intersecting y-axis at 1.5 volts. Then we can get EMF of the battery is 1.5 volts. Then part G1. What is the short circuit current in ampere that can be obtained from the given cell? Give your answer to 2 decimal places. Short circuit current means the current through the cell when it is short circuit. Like this. There is no any resistor in the circuit, but there is the internal resistance of the battery. Therefore, we can use Kirchoff law, or V equals IR to the this loop. Then I will write the relationship V equals IR. We can use Kirchoff law or this one. EMF is 1.5. Internal resistance, we have to find the I value, short circuit current. Internal resistance 5.75. Then we can simplify it. We can get 0.26 amperes. Part 2. What is the maximum power that can be obtained for the cell by connecting an appropriate resistor? we have to remember, to get the maximum current, maximum power, the external resistance should be equal to the internal resistance. Now we have to find the maximum power. You have to remember that we can observe maximum power when using a cell. The external resistance should be equal to the internal resistance of the battery. It means it is like this. Now we know that EMF is 1.5 volts. Internal resistance we have found 5.75 ohms. Now the connected external resistance should be also 5.75 ohms, equal with internal resistance. Therefore we can get maximum power of cell I squared R. There are three relationships for power: VI, I squared RO, V squared over R. Now we know the I value in part 1G. Therefore we can use I squared R. It is the maximum power of the cell. When calculating maximum power of the cell, we have to use the internal resistance of the cell as the resistance. Then the total resistance, equivalent resistance of the circuit is 2 times the resistance, 2 times the internal resistance. Therefore, current should be half of the above calculated value. It means 0.26 divided by 2. Half of current calculated in part 1 square. Simple R is internal resistance 5.75. We can simplify it. Then answer will be 0.097 volt. Then part H, if the same experiment is done for a nickel cadmium cell having a lower EMF and lower internal resistance, sketch the expected line in the same width given in F. Lower internal resistance and lower EMF. We know that when the EMF is a lower value, intercept should be less than previous graph. And when internal resistance is a lower value, gradient should be less than the previous graph. Then if the previous graph is this one, the new graph should be like this. Gradient is measuring angle, gap is a small value, and intercept means the intersection point of y-axis and graph, it is smaller than first graph. We have to draw rough sketch like this. Then drawing the second line, we have to draw it in the same coordinate plane in the given structured paper.